Welcome to Web Handling. My name is Dave Roysum. I am very excited to begin a new series on some of the most unpleasant issues in the web industries. That is, waste, delay, and customer complaint. In this first clip, we will briefly introduce the economics of opportunity costs. This is intended to put everyone in the same frame of mind that engineering has limitations. To get more meaningful answers, we need to start thinking in terms of money. In subsequent clips, we will offer very different ways to start thinking about the web handling and other issues that you work on every day. Some will be truly unique ideas. Some will be quite controversial. But all will hopefully inspire you to move beyond mechanistic and, as often the case, oversimplified thinking about web processes. When I go into a plant, I am often assigned a particular problem or set of problems. Example problems might be wrinkling or winding issues. My goal would be to identify which specific kind of wrinkle they have, why we know that it is that kind and not some other kind of wrinkle, and to know this by more than one line of reasoning or observation. Once we know which specific kind of wrinkle, for example, then we know what are the options for remedy. That remedy list then leads to opportunity costs versus remedy costs that the client can work out on their own. However, very often, I want to get a sense of the economic environment in which the client is working. There, I will ask, what are the top 3 causes for waste, delay, and customer complaint? Sometimes they will know, and sometimes not. Then I will ask, how much do each one of these individual problems cost the company? Often engineers do not know, for example, how much a minute of downtime is worth or how much a returned roll costs. Why do I get into this economic distraction? Well, there are many reasons. For example, it may be that wrinkling waste is also showing up on delay and customer complaints. If the latter, we know that inspection is not robust. If absolutely no wrinkles reach the customer, then internal rejection might be too good. I will explain the idea of producer-consumer risk in another clip if we have time. Sometimes the top causes may be related. For example, registration can be a big issue with printers, and registration can also be ruined by bagginess, which is a subset of wrinkling. Thus, registration, bagginess, wrinkling, and also gauge control on the supply rolls may all be related. Thinking too narrowly will cause incomplete understanding and, more importantly, as a consequence, misses opportunities. Note, however, that we are still quite focused why wrinkling occurs in the first place and what we can do about it. It is just that, in this example case, wrinkling may be interwoven into waste, delay, customer complaint, and purchasing or upstream manufacturing, depending on where your supply rolls come from. Another reason for an economic overview is to assess an appropriate level of response. If customer complaints are a few parts per 1,000, then we know that improving this is going to be brutally difficult and brutally expensive because waste is already so low. If, on the other hand, customer complaints are several percent, and especially several tens of percent on perhaps a more difficult product, then we know that the client may be at great risk of losing his customer, and we had better work quickly and effectively before the customer turns sour and we no longer have end-use customer as a problem-solving partner. The first part of comparing what seems to be apples and oranges types of issues is simple. That is, what units do we use for advanced troubleshooting? The answer is absolutely straightforward. It is dollars, euros, shekels, or whatever your local monetary units are. Thus, downtime measured in minutes is totally useless for economic troubleshooting. Thus, customer complaints measured in the number of rolls returned per year is totally useless for economic troubleshooting. The next part is a bit more tricky, and that is to assign costs for these various areas. We will let industrial economists weigh in with the better answers, but let me just summarize for simplicity. The cost of waste is very approximately the operating cost, including overhead and raw materials, plus lost profit and minus any recycle value the waste may sometimes have. Sometimes the recycle value is negative if you need to take it away to the landfill. The costs of downtime are similarly nuanced, but are very approximately the operating costs minus raw materials, this difference being mostly labor, plus lost profit. Finally, the cost of customer complaints is no less nuanced. Certainly it includes the direct payment of claims. However, this also includes labor costs to investigate the claims, as well as attempts at mitigation, which in total could be far higher than the claims themselves. More importantly, it should also include the costs of the risk of losing that customer and all of the profits that would then disappear until marketing found some other customer to fill in that capacity. Thus, a straightforward assessment of customer complaints by merely adding up claims greatly underestimates the true costs. So, while costs in dollars are not as straightforward as pounds or kilograms, you absolutely need to think in those terms if you are to be an effective troubleshooter. As engineers, we won't directly be involved in how to calculate these rates, but we should know what management calculates these rates to be. In the next several clips in this series, we will explain why an engineering view can be quite limited and why economics is needed to get better answers. In the next clip, for example, we will illustrate the idea by answering the question of what is the optimum tension to run a particular web machine at? Here, we will see that the optimum tension does not have an engineering answer, only an economic one. Stay tuned.